Hello and welcome to this episode of Benchmark BITESIZE, where we're going to be exploring the benefits of combining your cost modeling and your carbon footprint modeling in one tool. So this video is going to be targeted at the packaging professional and the LCA professional. So those acronyms that I'm going to use and phrases and talking about the production process and the different things we do in our industry, we will be assuming some knowledge. There will be other videos on the Benchmark BITESIZE channel that if you wanted to view those, that covers off some of the more basic things, you'd be more than welcome to go and view those. So to get straight into the topic today, the importance of combining your cost model and your carbon footprint model is mostly to do with data accuracy, consistency, and really convenience and cost for yourselves in the packaging industry. So to start with some of the key things that you need to do when you're doing a life cycle assessment, firstly, you need to make sure that you're using the best data sets that are available, the most complete data sets that are available, to make sure that you really get the granularity of information that you're using and you're not using averages as best as possible. And you also need to be very mindful of waste. What a lot of data sets will do, in fact, all data sets will do, they'll give you a base set of data which does not include waste, and it's up to yourself, the life cycle assessor, to add those waste considerations, really specifically to the production process that you're running. You'll see here that I am sharing our screen. I'm going to run through an example of a life cycle assessment and how the benchmark system FORENSIK will manage that and really give you the granular level of detail that you'd be looking for. So one of the other things that you need to make sure you consider as a life cycle assessor is the consistent scope and specific unit that you're using within your life cycle assessment. So some data sets will include a scope 3 level of data, others will not. Some will have delivery and haulage included, at least at some level as an assumption. Others won't, and also end of life considerations. Some consider, what might happen on average within that region at the end of life, and again, some don't. Second to which, there is typically speaking a 35-year and 100-year assessment for the impact of the raw material and the ingredients that you're using to make your products. Generally speaking, the 100-year assessment is considered to be the correct data set to use within the packaging industry, because some of the ingredients and chemicals and things that we use to produce the packaging materials that we produce do take upwards of 35 years to degrade and really become nothing and be fully absorbed into our environment, and in which case the 100-year impact is considered the better option. So further than this, we need to consider the level of detail we need to go through to really be as true and accurate as possible. Now, firstly, why is this important? Greenwashing would be the first one, and really making sure that you can stand up to reproach and audit on your sustainability claims. This is becoming a more and more important area of our industry. That marking your own homework and doing your own life cycle assessment is fast becoming something that really should be considered something that you shouldn't do. You should rely on a reliable third party to do this type of thing is the best advice and guidance from the UK's Green Claims Code. And what we try and promote with that is, if you consider the level of detail that you go to in pricing, you should also consider that level of passion for detail and accuracy that you all have when it comes to quoting a customer a price. We would advise that you take that same level of passion and accuracy with your carbon footprint assessment. So let's show a simple example. We're going to run through an example today on the benchmark system of a wet wipes pack. So a 12 micron polyester to a 40 or 50 micron polyethylene, solvent that's laminated, printed 8 colors, and used for a typical wet wipes pillow pack with maybe a label over the top for the easy opening facility. So printers, something that a lot of the industry is going to be very used to. Obviously, when it comes to pricing, we wouldn't consider, for speed, for example, a simple average speed. For pricing, we would consider that really for a tiny small order quantity, say 5,000 square meters, 3,000 square meters, you're not going to achieve the machine's full potential speed. So here's a great example where you can see order quantity driving machine speed, that actually as the order quantity increases, so we get up to the machine optimum speed, which is in this case 300 meters a minute. As we come down, you can see there's also a consideration for material thickness against running waste. And so maybe not true on the most modern of machines, that material thickness on a print machine can actually dictate the waste percentage. Then, of course, you've got the setup time and setup waste. Now, time on the machine we have to consider is also waste as well. So in carbon footprint modeling, of course, the more time we spend on a machine, the more energy we're going to be using, and therefore that waste has a consideration in its life cycle impact assessment. So we do need to make sure that we're capturing as best we can a consideration for waste. And again, those considerations for setup waste, for the wasted raw materials, and the time for the wasted time during setup, for ink matching, color matching, and plate registration, those things need to be considered, because all of those will drive extra time, which is extra CO2e, and extra waste, which naturally, the more product we waste during our production process, the more CO2e we're going to have. Now, from a cost modeling perspective, we would take the amount of minutes and hours used on a machine for a particular estimate, we'll multiply that by the machine hourly rate. For carbon footprint modeling, we're capturing the machine running energy usage in kilowatts, and also the energy usage during setup, because naturally you're not going to use quite as much energy during setup as you would do running, and then the indirect energy usage apportionment as well. So obviously you're going to have lots of other ancillary equipment, you're going to have the office lighting and potentially air conditioning, and if you're in a particularly hot environment, all of that, in the same way that you do an indirect cost apportionment through your budget process, we take the same approach with regards to the indirect energy apportionment to the machine from a carbon footprint modeling perspective. Now, of course, these numbers need to be multiplied by the site level setting, which says what's the carbon footprint for every kilowatt hour used within that region or country that you're producing, which, maybe you've got offsets as well with regards to solar panels and things. These can all be built in. But you see the level of detail, and I'm sure for a lot of you, this is something that you're very familiar with regards to your cost modeling activities. Again, what we're promoting here is that you should really be considering this for your carbon footprint analysis also. So then if you consider the materials, so this is where we talk about the waste consideration. So I just want to deep dive into one specific example here. So if we look at an LDPE, so this is EcoInvent 3.8, and it's the RER region, which is Europe. If you look at an EcoInvent report, those reports come with a huge amount of detail. And if you look at this EcoInvent report, again, this is the 3.8 RER report that we're looking at here. There's a really nice summary at the beginning talking about how the report was generated and the work that went in to produce that. It also talks a lot about what is included and excluded and the scope of this particular assessment that's being done. So we capture that and we maintain our own data within Benchmark as well. And you can see just an extract of this as well, where you can see the polyethylene production, low density grade. You can see the 3.8 EcoInvent report for Europe. And then you can see the general comments summarized, what is included at activity start, what is included at activities end. So it's absolutely critical that when you're doing your own life cycle assessments, if you choose to go down this road, that you really choose consistent data points, that the general comments and particularly what's included at the start of the activity and the end is consistent. Are you including waste or a consideration for it or not? Are you going to add this yourself? Is there haulage? All of those different considerations, and are we really looking at the cutoff data, the 100-year assessment? So once we've built up that full picture and we've got this level of granularity in the system where you can see, all the resins have their costs, they all also have their CO2e considerations. We then obviously have the consumable items, your other items, and I'm not going to go through these. These are really the tail end of your cost curve, where you're talking about your pallets, your cores, your delivery profiles, your secondary consumables for, zips and things like this. Now, once all that's completed, what I'm going to show you here is just a typical example of this wet wipes product that we're modeling here. So In the same way that you would go through and create an estimate, that you're choosing your production process, selecting which machines you'd like to use, you're then choosing your width and your cutoff within the print panel, which specification, which web is being printed, how many inks would you like to print. In this case, we're saying 8. And just for this example, typically you might not include them, but we've got our printing plates and absorbed in the cost as well. And for the CO2e, you've got your adhesive and web 2. And then finally, you've got your packing, delivery, and storage all the way through to the final part here. So when we get to the bottom, what you see in the benchmark system is the cost value in the black text for each order quantity, that you can see the order quantities across the top. And then in the green text, you can actually see the carbon footprint, the total CO2e impact over a 100-year impact, based on the numbers that we've entered into the system. And you can see all of this in one screen. Okay, and as we come down, we can see our financial considerations for the contribution margin scheme. You can see your cost breakdown for all of the key cost drivers, all the way through to total cost. And then naturally, if it's a quoted price, you're going to have your margin there on top. But most importantly, for today's call, you can also see the carbon footprint in the same key drivers as you can do the cost. So you can see where are the key elements that are driving the significant carbon footprint on this particular product. So you see the level of granularity that the benchmark system goes to, and the amount of data points that are being captured in the background. Now, naturally, maintaining this data is not an easy task, because there are a lot of data points. If you have a separate life cycle assessment tool to your costing tool, you're now paying for and maintaining 2 systems. Now, through your budget process, you will be maintaining the system, because, of course, as with most businesses, it's going to be critical and part of your business governance that you will be trying to keep as accurate and as realistic as you can your costs for pricing, as accurate as possible to the reality of your business. All we're doing here is taking that work which is already being conducted by your business and then using that same data to produce a carbon footprint assessment. And really, this level of granular detail means that you can never be considered greenwashing, because the same data points that are being used for pricing that drive your business's profitability, of course, are then also being used for your carbon footprint assessment. So if, as we're expecting the world to progress and the rules and guidance around carbon footprint modeling and anti-greenwashing to progress as the years go on, having a good backstory and having a good auditable process that goes behind your carbon footprint assessment is going to become more and more important as time goes on. So this is the solution that we have within Benchmark, within our forensic tool. Well, I hope you've enjoyed this video. I hope you found it useful. If you do have any questions, please reach out through the Benchmark team through our inquiries, and we look forward to speaking to you soon. Thank you very much.